So let's finish up our introduction to confidence intervals and confidence levels. So what we're looking at is how likely that what we're doing produces an interval that will capture the population parameter if we use it many times. A confidence level does not tell us the chance, it's not a probability. It doesn't tell us the chance that a particular confidence interval captures the population parameter. It simply tells us how many times we expect that interval to have the population parameter in it. Instead, what the confidence interval does is it gives us a set of plausible values for the parameter. And whether we're estimating population means or proportions or standard deviations or any other population parameters, we're going to proceed through this method in the same way for all of them. And so how do we do it? Well, first, why do we deal with 95% confidence? It's good, but it's not too good. It's the price we pay for greater confidence is a wider interval. In order to have more confidence, we need to have a much larger interval for our confidence interval. When we calculate our 95% confidence interval, we start with our estimate, our x bar or our p hat, plus or minus some margin of error. And our estimate came from the sample statistic, and our 95% determined that we are looking at 2 standard deviations from the mystery mean. So our confidence interval is 240.79 if that's x bar, plus or minus 2 times 5, 5 being the standard deviation of the means. And we can generalize that as x bar plus or minus 2 sigma sub x bar. And that leads us to this general formula for constructing a confidence interval. Statistic plus minus critical value, that's the 2, that's the number of standard deviations away from the mean we want to be, times our standard deviation of the statistic. And the statistic that we're using is a point estimator. There's that vocabulary word from the first video for the parameter. So we're using x bar as our statistic for mu. We're using p hat as our point estimator as our statistic for p. Things like that. Some properties. First, margin of error. That term is found by taking the critical value, the number of standard deviations, times the standard deviation of the statistic. That's the plus or minus part. The user, you, choose the confidence level, and the margin of error will follow from that choice, because the critical value depends on that confidence level. If we want 95%, we're dealing with 2 standard deviations. 2 is our critical value. We could pick other percentages, and that will change our critical value. But our critical value will depend on the confidence level and the sampling distribution of the statistic. Greater confidence requires a larger critical value. That should make sense. And the standard deviation of the statistic depends on the sample size n. The margin of error will get smaller when the confidence level decreases, because our critical value is now smaller, or when the sample size n increases. More samples lead to less variation, which will make our confidence interval smaller. So before we calculate a confidence interval, there are 3 conditions we have to check. 1, our data should come from a well-designed random sample or a randomized experiment. 2, our sampling distribution must be approximately normal, and we saw this in the previous chapter. For means, either the population must be normal or the central limit theorem must apply. That is, n must be sufficiently large n greater than or equal to 30. For proportions, we can use the normal approximation as long as np and n1 minus p are both greater than or equal to 10. We saw both of these last chapter in using a normal approximation for sampling distributions. Those conditions still hold when we're constructing our confidence intervals. And finally, our individual observations, our trials, they must be independent. And if they're not independent, if we're sampling without replacement, the sample size n should be no more than 10% of the population. That is our 10% condition. We saw that last unit also, and we need this condition to be in place to use our formula for the standard deviation of the statistic. So here is a quick summary of all the things that we have talked about in 8.1.